All right, let's look at 1B. We have three different complexes to look at here. Again, first we need to figure out what the oxidation state is on the metal. This is a cyanide ligand, and you need to know that. And each one of those cyanide has a -1 charge, so those cyanides are contributing -6. The overall complex anion is 3-, so this must be iron 3. Well, iron 3+. Iron 0 is a D8 electron configuration. Therefore, iron 3+ is a D5. But in this case, it's low spin D5. So what does that look like? 1, 2, 3, 4, 5. All of them in the T2G set, low spin D5. And so the crystal field stabilization energy is equal to 5 times -2/5 delta oct. Okay, the bottom set always contribute -2/5. And so this is -10/5 delta oct. And I know you could simplify this to -2, but it's often just makes the most sense to leave all of these as, as fifths instead of simplifying the ones that you can, so it's more easy to compare. All right, we have another complex here. So we have this is a complex anion and chloride. There's 3 chlorides, so there's 3 minuses from the chloride. The waters are neutral, so they contribute no charge. And therefore the metal must be ruthenium 0 that we have here. So 0 plus 0, 0, 0, -3 gives us a -3 overall. So this is ruthenium 0, which is a D8. Okay, so now we go and put our levels, and we say that it's low spin, but in fact there's not a low spin, high spin for D8. Just don't want to give that away right away. So 6 of the 8 electrons, 7, 8. So now let's do our crystal field stabilization energy. It's 6 times -2/5 delta oct plus 2, let's put that down here, plus 2 times +3/5 delta oct. So -12/5 delta oct plus 6/5 delta oct. So 6 minus 12 gives me -6/5 delta oct. That's the crystal field stabilization energy. All right, last one for right now. The carbon monoxide is a neutral molecule, neutral ligand. Cyanide is a -1 ligand, so -1 -1 is -2, and the overall complex anion is -2, and so this must be chromium 0. Chromium 0 is D6, and we said this is D6 low spin, and low spin, high spin is a thing for D6. So 1, 2, 3, 4, 5, 6. We have 6 electrons in the T2G. Okay, so my crystal field stabilization energy is equal to 6 times -2/5 delta oct, which is -12/5 delta oct. And so we see, and if we combine this with the 1A examples that we worked out, that the crystal field stabilization energy ranges from a maximum of 0 to a minimum of -12/5. This is the most stable crystal field stabilization energy, is for a D6 low spin configuration.